Let's dive right into how we actually build object-oriented designs using Python. Our core objectives here cover everything from creating classes to adding attributes and behaviors. It's all about bringing structure to your code. Creating a class in Python is remarkably simple. We just use the class keyword followed by our chosen name, like my first class. If we aren't ready to add any logic yet, we simply use the pass keyword to tell Python that no further action is needed right now. Notice the naming convention. We use CamelCase for classes, meaning each word starts with a capital letter and there are no spaces. Also, Python uses indentation, specifically 4 spaces, to define what belongs inside that class. Once our class is defined, we can create objects from it. This process is called instantiation. Here we create two objects, A and B. Even though they come from the exact same class blueprint, look at their memory addresses down here. They are distinct entities with unique memory locations in your computer. Now, an empty object isn't very useful. We need to store data, and we do this by adding attributes using dot notation. Look at this point example. We can assign values directly by saying p1.x equals 5 and p1.y equals 4. These coordinates are now stored safely within that specific object. Objects also need to perform actions, which we call behaviors or methods. Let's look at defining a reset method for our point class. It's defined just like a standard function, but there is one absolute rule: the self parameter. Every method must have self as its first argument. It's a reference back to the specific object calling the method, so Python knows exactly whose x and y coordinates to update to 0. Internally, calling p.reset is exactly the same as explicitly calling point.reset and passing p as the argument. Python just handles passing the object for you. If you ever forget to include self in your definition, like in this broken example, your program will crash. Python will throw a type error saying 0 positional arguments were expected, but 1 was given. It tries to pass the object in automatically, but there is no parameter waiting to catch it. Finally, methods can take multiple arguments for more complex logic. Take a look at this distance calculation between 2 points on a graph. The mathematical distance formula is implemented easily using standard operations like math.square root and squaring the differences. To verify our logic is bulletproof, we can use an assert statement to ensure the calculated distance is identical regardless of which point initiates the calculation. If that logic ever fails, the assert statement will immediately flag an error. The key takeaway is that classes provide the blueprint, but objects are the unique distinct entities in memory that hold their own attribute data and use self to manage their own behaviors. Before we can use these attributes reliably, we need to ensure our objects are fully set up from the moment they are created, which brings us to special initialization methods. Let's imagine you create an object, but you try to access its attributes before they've actually been assigned. In Python, this raises an attribute error. It basically means your object is incomplete. It's in a broken state. To prevent this, we need a way to initialize our data safely from the very beginning. Let's focus on initializing the object. Python handles this using a special initialization method named init. You'll notice the double underscores around it. Developers often call this a dunder method. This tells the Python interpreter that it's a special built-in method. So how does it work? As you can see down here, this special method runs automatically on creation. When you write something like point equals 0.3, 5, Python immediately looks for the init method.
By putting the logic self.move x, y right inside init, we force whoever is using our code to provide those coordinates the moment the object is instantiated. This completely prevents that broken state. The object is immediately loaded with its data like x equals 3 and y equals 5. But what if we want to make those arguments optional? Let's move over to default arguments. We can use an equal to sign right in the parameter list to provide a safety net. Here we have written x equals 0, y equals 0. These are our fallback values. If a user creates a point without passing any numbers, just an empty point call, Python gracefully falls back to 0, giving us fallback values. On the other hand, if they do provide numbers like 0.3, 5, Python ignores the defaults and uses those specified values. Just a quick note down here at the bottom, you might hear about the new method. While init initializes the data, new is the actual constructor that physically allocates the object in memory before init even runs. It's mostly used for advanced metaprogramming, so for everyday code, init is exactly what you need. Now, writing code is only half the battle. Explaining it is just as important. Python makes this easy with documentation strings, or docstrings. A docstring is simply a string literal placed as the first line under a definition. You can use triple quotes for multi-line descriptions, like this one that says it represents a point in 2D space. A good docstring should summarize the purpose, explain the parameters, and show how to use it. Here we have a fully documented class that clearly explains what calculate distance does and the math behind it. Why go through this effort? Because when someone runs the help command in their terminal for your class, Python automatically takes all those docstrings and generates a formatted manual. This empowers other developers to understand and interact with your code beautifully without ever needing to read your raw source files. Ultimately, by properly initializing your objects and clearly documenting your classes, you ensure your Python code is robust, user-friendly, and maintained.